Hello everyone. Let me start with a curious thought. Did you know that every time you open a book, you are actually creating pairs of angels? Yes. The crease of the book acts like a line, and the pages on either side form angels. Now imagine, if you push the book open completely flat, those two angels together form a straight line, and that's exactly 180 degrees. So today, we are going to explore the fascinating world of pairs of angels, complementary, supplementary, adjacent, linear pairs, and vertically opposite ones. Let's see how these little angle friendships shape our geometry. Think of a clock at 3 o'clock. The hands of the clock form a right angle, that's complementary. Now stretch it further to 6 o'clock, and the hands are in a straight line, that's supplementary. Mathematically, we define complementary angles to angles whose measures add up to 90 degrees. Supplementary angles to angles whose measures add up to 180 degrees. Adjacent angles to angles that share a common vertex and a common arm but don't overlap. Linear pair, when adjacent angles lie on a straight line, they always sum up to 180 degrees. So, whenever you see angels side by side, check their sum. That's the magic of angle pairs. Now, let's carefully look at the linear pair axiom. Axiom 6.1 states, if a ray stands on a line, then the two adjacent angles formed are a linear pair and together equal 180 degrees. For example, imagine line up with a ray OC standing on it at point O. The angles formed are angle AOC plus angle BOC equals angle AOB equals 180 degrees. So, in simple words, a linear pair is just like two friends who always complete each other to make a straight line. Here's an interesting flip side. Axiom 6.1 states, if the sum of two adjacent angles is 180 degrees, then their non-common arms form a straight line. Example, suppose one angle measures 125 degrees and the adjacent one measures 55 degrees. Since 1 to 5 plus 55 equals 180, their outer arms must lie along a straight line. It's like saying, if two pieces of a jigsaw puzzle perfectly add up to a rectangle, then you know they are placed correctly on the same line. This axiom is not just theory, it's extremely useful. For instance, if one angle in a linear pair is 70 degrees, the other one is simply angle equals 180 degrees minus 70 degrees equals 110 degrees. Such calculations are the building blocks of geometry problems, especially when dealing with triangles, polygons, or even architecture. Now let's move to an even more exciting concept, vertically opposite angles. Theorem 6.1 says, when two lines intersect, the vertically opposite angles are always equal. Picture lines AB and CD crossing at point O. The pairs formed are angle AOC equals angle BOD and angle AOD equals angle BOC. A real-life example? Look at a pair of scissors when the blades cross. The opposite angles where they intersect are equal. That's the vertically opposite angle property in action. Let's quickly prove this theorem step by step. Step 1. At point O, angles AOC and AOD form a linear pair. So, angle AOC plus angle AOD equals 180 degrees. Call this equation 3. Step 2. Similarly, angles AOD and BOD also form a linear pair. So, angle AOD plus angle BOD equals 180 degrees. Call this equation 4. Step 3. Since both equal 180 degrees, set them equal. Angle AOC plus angle AOD equals angle AOD plus angle BOD. Step 4. Cancel out angle AOD and we are left with angle AOC equals angle BOD. And by the same logic, we can prove the other pair as well. Done. This proof is neat because it uses only the linear pair axiom without any complicated constructions. So, to wrap up, linear pair axiom says two adjacent angles on a straight line always sum to 180 degrees. Converse axiom says if two adjacent angles sum to 180, their arms must lie in a straight line. Vertically opposite angles theorem says when lines intersect, the opposite angles are equal. Every time you see roads crossing at a junction or even notice the blades of a fan, you are looking at pairs of angles in action. And that's the beauty of geometry. It's not just inside your textbook, it's everywhere around you. And that's the foundation of pairs of angles. In the next video, we will explore how these angle pairs help improving angle sum property of triangles. Stay tuned.